In this video, we're going to have a look at how we use trigonometry to find the lengths of any unknown sides in your triangle. First of all, let's review what basic trigonometry is all about. It's to do with right-angled triangles, must have a right angle here, and we use the terminology of hypotenuse, which we should remember from Pythagoras' theorem. But notice this triangle here also has an angle associated with the triangle, which Pythagoras didn't have. The other two sides in trigonometry are known as the opposite side, which is always opposite our reference angle, and then the side next to the angle there is called the adjacent side. We shorten these sometimes just to being O, A, and H for hypotenuse. Now, the ratios that tie these three sides together are known as sine, cosine, and tangent. This little symbol here is a Greek letter and it's called theta. And in mathematics, that's just our default symbol for an angle. So whenever you see a theta, it usually means an angle. Now, the sine, cosine, and tangent are always linked to the angle. The sine, cosine, and tangent are just operations that we do on our angles. Now, these ratios, sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, tan theta opposite or adjacent, are essential ratios for trigonometry, and they're the ones that we use over and over again. To help you remember them, we shorten them to SOH, CA, TOA. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. This little saying SOH, is the backbone of basic trigonometry. So let's put it in action and see how we use it to find unknown side lengths. Let's have a look at this triangle here. Find the length of the unknown side, which in this case is x, in the following triangle, and round your answers to 2 decimal places. Now here I've put all of the steps that you need to follow every single time you solve for a triangle. First of all, we've got to label our triangle according to our opposite, our adjacent, and our hypotenuse. So hypotenuse is the easy one. That's always the longest side, and it's always opposite this right angle here. So the right angle points to the hypotenuse. Here's our reference angle, 56 degrees. The side that's opposite that is our opposite, and the one that's left is adjacent. So once we've labelled it, we've now got to decide on which trig ratio we're actually going to use to help solve this triangle. So having a look, hypotenuse, we've got a length on that, so that's part of the game. Our opposite, that's the one we want to find. Adjacent, even though we've been able to label it, is actually not part of our working out because there's no length on it and it's not what we want to find. So we've got hypotenuse and opposite in this problem. Now you need to have a look at your SOH and see which one of these three involve opposite and hypotenuse. Opposite, hypotenuse, we're going to use sine in this question. So which trig ratio we're going to use? It's going to be sine, and we need to write down the formula. So we start every calculation with the formula, and we know that sine theta is opposite over hypotenuse, because that's what this says. Sine theta is opposite over hypotenuse. So we've labelled the triangle, we've decided on sine, we've written down the formula. Now we're going to substitute the values from your triangle. We're basically going to fill in all of these unknowns with values that are associated with our triangle here. So sine, now this theta, as I said before, is always the angle. The angle in our triangle is 56, so we put 56 in there, equals opposite. What did we have on the opposite side? That was our x. over the hypotenuse. On the hypotenuse we had 14, so we put that in there. Substitute values for our triangle. We've done that. The next is solve for your unknown value. The unknown in our triangle, of course, is this x. We want that to be solved. So we need to employ some of our algebra skills. We want to get x by itself. At the moment it's got a divided by 14 on it. We need to use inverse operations. Opposite of divided by 14 is multiply by 14, and we need to do it to both sides to keep the balance. Now the beauty of doing that is this divided by 14 times 14 is cancelled out. So I've now just got x left. So x equals 14 times sine 56. And you need to go to your calculator now. Now you key this in exactly as it appears on the screen here. So 14, I'll give you a chance on your calculator, have a go. Key in the 14 and the times, your sign button. Now you'll notice when you do that, if you on your calculator do 14 times and then you press the sign button, it will automatically on your screen come up with sign and open a bracket. Just put your 56 in there and then close your bracket and press enter, and you should get that x is 11.6065, etc. Solve for the unknown value. Done. The very last thing you do is just check if you needed to round to a certain number of decimal places, or if in your triangle it says that it's centimetres or millimetres, make sure you put your units on as well. Our rounding in the question up here, round your answers to 2 decimal places. So let's have a quick review of how to do that. 11 point, there's my first decimal place, second decimal place. So I've got 11.60. My only thing I've got to check is if this number now is 5 or more, I'm going to round up, which it is, of course. So I'm going to go 11.61 is my answer rounded to 2 decimal places. The working out for your trig is going to be exactly the same every single time. The only thing you need to check is if you're using sine or cos or tan. Every time you do one of these and your unknown ends up being in the top of your fraction, the working out is going to be exactly the same. Sometimes though, when you do your triangle, this x, the unknown, ends up being in the bottom of the fraction. Let's have a look and see how you do that one. Here's another triangle. Find the length of the unknown side, again rounding to 2 decimal places. Let's go through the same steps. Label the triangle. Okay. Here the right angle is pointing to my hypotenuse. My angle, opposite the angle, is there. Adjacent is here. Now once again, I've got a hypotenuse and I've got an opposite. There's nothing on the adjacent side, so that's not part of it. So the trig ratio, I'm going to use sine again. Remembering about SOHCAHTOA, the opposite hypotenuse tells us to use sine. So let's write down the formula. Sine theta is opposite over hypotenuse. Next, substitute the values from the triangle. Sine, my angle is 35. Opposite over here is 245. Hypotenuse here is my unknown, that's my k. Now have a look what's happened now. My unknown is in the denominator of my fraction. In the previous example we did, the unknown was up here on the top. So we need to change the way we attack this as far as our algebra goes, because the next step is to solve. Now on the previous page, we just multiplied by what was in the denominator. So let's do that again. Let's just see what happens. So multiply by k, and then you'll find that this k and that k cancel one another out. So I'm left with k times sine 35 is 245. Yes, it got rid of the k out of the denominator, but I still don't have it by itself. It's still over here, and it's got sine 35 attached to it with a times. I want to get k by itself, so I need to get rid of that. So what I'm going to do is do the opposite of times sine 35 and divide both sides by sine 35. What that's going to now do is cancel those two out, and I'm going to be left with k being 245 divided by sine 35. Your calculator is going to do the rest of that. Have a go now. 245, and then you do your divided by sine, and again remember it's going to open a bracket here, just close it again, it doesn't matter. The important thing is you don't rub it out, otherwise the whole thing falls apart. So k then equals 427.1444. So I've solved. Now I've just got to check my rounding. Once again, it's asking me for 2 decimal places. 2 decimal places. This number here is only a 4, so I'm not going to round up. I would leave it as 427.14. If there was units on my triangle, if this said centimetres or millimetres, I would add them here, but it doesn't, so we can leave it as is. So let's go back to have a look at this working out. Any time your unknown is in the denominator of your fraction, this is the working out you're going to do, multiplying by k or whatever unknown you've got, and then dividing by your trig ratio. It's always going to be that same process each time, and you're going to end up with a division problem as your final working out. Over on the previous page, every time your unknown is in the top, you're going to end up with a multiplication problem as your final calculation. So you can sort of think about this one as being a type 1, if you like. So a type 1, your unknown is in the numerator, which you know is the top of your fraction. Anytime your numerator is in the top of your fraction, your working out is going to be like this. The only thing that's going to change is whether it's sine or cos or tan. This sort here you can think of as a type 2 question, where your unknown is in the denominator, which you know is the bottom of your fraction. Oh, yeah, in the bottom of your fraction. Anytime it's in the bottom of your fraction, you know you're going to do this working out. The only thing that's going to change is whether you've got sine, cos or tan. So anytime you're finding the unknown length of a side, your working out is going to be one of these two type 1 or type 2 calculations.